Hey guys, this is Chung. So from today, I'll be doing some LeetCode problem solving videos since I'm also doing LeetCode problems. And I've been doing LeetCode problems for a while, and then I figure out it's a good idea to make some videos, not only to share some of my knowledge and my experience, but also maybe to better to improve my own English and my presentations during the interview. Yeah, sorry, pardon my English since it's not my first language. Yeah, it's my second language. So yeah, okay, and okay. So today, uh, the problem is called the design snake game. If you guys haven't played this game before, there's a link on this problem where you can just go have a have a quick play. So what this what this problem is, okay, so you'll be given a width and height here. So basically, this width and height defines the boundaries, so right, the play area. So as you can see here, the width is 3, so basically 3 by 2 matrix here, and then there'll be a food list. So the food list is a bunch of coordinates. Basically, the first one is appears at 1 and 2, which is here. Second one will be 0 and 1. Well, 0 and 1 is just here, right? And uh, and then basically we initialize this class by giving this three parameters, and then uh, we'll be implementing this move method. That's the core piece of this problem. So what does this method do here? So it will do four things basically. It will give you based on the directions, up, left, right, and down. So the snake will be moving into one of the four directions, and you are supposed to check if this move it is valid, right? If it's not valid, you return -1. If it is valid, you return the current score. So the score means basically how many food have you eaten. And so, what does this snake do, right? Every time when it's moving to one directions, what does it do? Basically, it's move its the whole body, right, to the next location. What does this move mean, right? It means you the head of the snake will be moving to the new direction. It will be at the next location. And then what? And then the tail of the snake will be also moving to the same direction. And so this is the question. So when I thought this problem, it didn't take me a long time to come up with the queue data structure, right? So what does it mean? So every time when the snake move, you'll be adding the new location to the head to the beginning of the tail of the queue, and then you will be moving the last element from the tail, right? That's how it's kind of simulation of the move of the snake, as we can see here, right? Since this is the last, there's only one element. The length of the snake is 1. So once it's moving to this direction, right? So what does it do? It add the the next element, the next position to the head of the queue, and then it remove the last one from the queue, right? So it's right here. And so and then what? And then once you reach the food, right? What does it do? Once you reach the food, basically you just increase your length by 1, which means you only need to append, right? And then you don't need to like remove from the tail. Okay, so I know it's my explanation is kind of terrible. It's my first video, YouTube video. So let's see. So basically, if this is a snake, right? If this is a snake here, if the snake has a length of 2 here, and this is the head, this is the tail, and we're moving to this direction, right? So by 1, basically, let's assume this is the next direction. What does it do? So basically, the head will be here, right? The head will be here, and the tail will be here. So what? So basically, see, so we just add. This is the Q, right? This is the Q, and we add the first one. The Q before the Q has tail and head. We're we're storing the locations in this queue. We're not storing any values, right? Only the locations. So this is the location of that. So we add this one, add this to the add this location position here to this queue, and then we remove one from the end. Okay. Uh, not sure how much sense will it make, but okay. Um, let's go into the coding. Yeah. Okay, so okay, so we have the width here and the length. So first will be okay, initialize some of the method here. So the variables. First one is the width, right? So we'll be using those variables to check the boundaries, basically. Width, so height, and then what? And then also, of course, the foot and the snake, the body, the Q of the body. Since we'll be using a Q, and then we'll collections dot collections dot DQ using a DQ, and since the snake will always start from the position 0, 0, we'll be initialize this snake with 0, 0, and the last one will be the score. Score will start from 0, right? And then the move. Okay, so the move. So what do we do? So first we have to remember. So and the first element of the queue is always the head of the snake, right? So we'll be getting the head of the coordinate, the head, uh, row, and head count from the queue, right? We just do a -1, right? Since it's the top one, the rightmost one, basically. And then we'll do a if check here. We check all the directions here. Directions left, right? Sorry, left. What do we do? We do if it's going. Sorry, it's going. Yeah, I'll follow the description here. If it's going up, then which means the head of R will be decreased by 1, right? Else if direction goes to left, and left means the column, right? The column will be decreased by 1, and else if direction is to right, okay, then it means the head of right means the column will be increased by 1. Okay, I believe it's pretty straightforward, right? Directions down. The last one is down. Down means the row will be increased by 1, right? So now we have the next position of the head. So we do a boundary check first. If to check if the new the next the next location is in the boundary, is within the boundary or not. So we do a row less than 0 or greater than the row means the height, right? So -1 or C small less than 0 or same thing or the new column. Yeah, sorry about my typing. It's hard to type while talking. Yeah, and self dot uh, with yeah. Basically, if it's not if it's outside of the boundary, it's return -1. Okay. So if it's in the boundary, what do we do here? So first we check if this next location is the food or not. If the okay, so we do a if self dot right. If there's still some food left, and this new location had its coordinates basically is in. Sorry, it's not in. It's equal to the next food. The next food will be the first food, right? Starting at 0. If it's there, what do we do? Like what we said, we simply append uh, the queue, append this new position, append this thing, new position, this new location to this queue, right? And then what? And then we need to remove the food from the list. Sorry, since it's the first one will be removed. It's a list we'll be removing from the beginning. And then remember, don't forget to increase the score by 1, right? Okay. That's when you see a food, right? If there's no food, if it's a regular thing, if it's a regular movement, what do we do? First, like we said, we remove the 1 from tail. Basically, since it's tail, we do a pop left. And what do we do? Okay, now we check if the snake will run into itself. If it's run into itself, it will be basically it will dead, right? It will be dead, so it's invalid. So how do we check? So since the snake already removed one from the tail, and then we check if this new position new position is still in is part of the snake itself, right? So what does it mean? So if still in the snake, which means it will run into itself, right? Then it's not valid. So we do a -1, return -1. Else, right? Else what? Else we just if everything is okay, we just simply add the next this new position to the beginning of the snake, like which will become his new head, right? Sorry, R. C. Okay. In the end, we just return that self score. Okay. Uh, -1 minus. Yes. Ah, damn. Okay, so here, right? Yeah, I don't know what was I thinking. So let's run again. Mm, uh, okay, so or here. Yeah. Okay, now Yeah, cool. And yeah, just to do a real quick recap here. We initialize here and we get the head of the snake, and then we check the next we based on the direction we check the next the we get the next position, and then we check the boundaries. Then we check if the next position is the foot, right? If it's the foot, we just simply up, append this new position to the head, and then we remove the foot, the first foot, we increase the score. If it's not foot, we pop one from the left. Or yes, notice that we need to check, we need to pop the one from the left from the tail first before checking this thing here, right? Because the snake will be moving, right? Yeah, assuming, okay. Yeah, assuming this snake here, let's see the snake is here, right? Let's say this is the tail, and this is the head, and it's moving up, right? It's moving up. So what do we do? So don't, if we just if we check this one before removing one from the tail, right? If the head one is going up, so the next one will be here. So it's oh, it's in the queue, and then it's hitting right into the cell, which is not, right? So you can see here. So once this thing goes up, the tail will be will also go to the right, right? So it will be here, right? And this place will be empty, which means this move is valid. Okay, right? So that's why we need to remove one from the tail first, and then we check if it's after removing the tail, if it's still in part one, if it's still in inside of the snake. If it is, then it's not true. It's invalid. Otherwise, we just move add the hat, right, and then we return the score. Cool. Okay. I know it's a bit long. I think I'm trying to explain as as clean as possible. Okay. Cool. Thank you for watching the videos. I'll be seeing you guys soon. Maybe tomorrow. Who knows? All right. Bye.